Welcome to the pre-calculus notes for Essential Skill D3, the ambiguous SSA case. In this piece, I'm going to give you given information, two side lengths and an angle that's not contained. And it turns out that we might have one solution, or we might have two solutions, or we might not have any solutions. So we're going to look at why that is and how to handle that. First, a little background on why this is ambiguous. It's all because of inverse sine. So, we know that sine of 30 degrees is 1/2. And we know that sine of 150 degrees is 1/2. Please refer back to notes D1 if you don't remember how to figure that out. That's with the unit circle. So if we want to solve the equation sine of x equals 1/2, well, x could be 30 and it could be 150, because both of those work. If we put this in a calculator, however, if we find the inverse sine of 1/2, we should be given an angle. Let's see what we get. We get 30 degrees only. It gives us no indication that 150 is also a solution. Let's see why that is. With these examples, we can figure out the pattern to what's going on. So take a moment, put these into your calculator, and find these sines. When you find those sines, find the inverse sine of your result. See if you get the angle back. Which angle do you get back? Here are the results you should get for the sine functions. Next, take the inverse sine of each of these results and see which angle you get back. In every case, it's the acute angle. Notice that there are some rounding differences. That's because I used inverse sine of the rounded figure instead of the full expanded decimal. So here we got 10 degrees, not 170. We got 45 degrees, not 135. And we got 78, not 102. So here's the point. Inverse sine will only find an acute angle. If there's another solution, inverse sine won't tell you about it. So you have to figure it out, because we might have obtuse angles in a triangle. Notice how these pairs, these angle pairs, add to 180. So to find the other possible angle, we will subtract from 180. If you use inverse sine, you must assume that there could be a second case. So, if there's a second case, then we have to find both possibilities. Let's take a look at what this looks like geometrically. Here's a case where I have an angle, a side, and another side. They are the two sides do not contain the angle, so it's angle, side, side. So here's what we know. We know 25 degrees. We know that there's a side of 9, and we know that there's a side of 6. What we don't know is how big is angle B. We don't know how long is side B. We don't know how big is side C. Since a side of size 6 will actually connect within a 25-degree angle in two ways, there are two possibilities. So here's how we deal with that. We have a set of opposite parts, which means we're going to use law of sines. It's our only choice. So here's law of sines. Here's where the problem lies. Inverse sine on the calculator is going to return an acute angle no matter what. But there might be a solution that's obtuse, and the inverse sine wouldn't tell us about it. So let's run it through the calculator. So, as expected, we got an acute angle, 39.340 degrees. Now, the sine of another angle, an obtuse angle, is going to have the same value, and so we subtract from 180, and here's our second solution. So here are the two possibilities for angle C. The acute case, given to us by inverse sine, and the obtuse case, given to us by subtracting from 180. In a full problem, we'll have to solve both of these possible triangles. Each has a separate value for angle B. Each has a separate value for side B. Let's look at a full example. We'll start with the sketch. My preference is to put the given angle at the bottom left. I have its opposite side as 15. I'm going to draw this way. I'll draw it two different ways. This will be 15. And then side B is going to be 19. I'm going to choose this side to be B. So maybe it looks like this, or maybe it's an obtuse triangle, like this. We're going to have to try both cases and see if they work. Now, since our first step must be law of sines, we're going to try the acute case first. See if it works. So let's see what the calculator says. I'm going to store this because we are going to use it later. I'm also going to take just a moment and figure out what the alternate version of B would be. So I'll subtract that from 180. I'll solve the acute case first. The next easiest thing to find is angle C. Notice that we can simply subtract from 180. Now the only thing left is side C. Since we have all the other information, we have a choice. We can either use law of sines or a law of cosines. For the purposes of demonstration, I'm going to use law of cosines. First, I'm going to store this angle so that we can keep max accuracy. And now, law of cosines. I'll abbreviate here just knowing that we're going to use the stored value and turn it purple. Remember that that's c squared. And case 1 is now solved. Now we look at case 2. In case 2, we found that the obtuse angle B could be 142, roughly. So our first task is to find angle C. Actually, I think the first task I want to do is store the new angle B so that we can use that shortcut again. So here's the new angle B, and we will store it as B. Now it replaces the old value. It will be good for this obtuse triangle. So this is about 9 degrees. So our final step is to find the revised side C. Once again, I'll store my new angle C as a variable to maintain accuracy. And now we'll go to law of cosines. While this might look like a reasonable number, don't forget, side C is opposite a 9-degree angle. It's going to be tiny compared to these two. Do not forget to square root this. And we're done with that problem. So, quick recap. We drew 2 sketches. One where B was acute, one where it was obtuse. We found the acute case using inverse sine. We took the original B, subtracted from 180, to get the starting value for the second case. Next, we found the third angle, and then the remaining side. In the second case, we found the remaining angle, and then the third side revised. This is our complete solution. Both cases, all the numbers for both cases. If I ask you to find the area of both cases, you'll need to use 2 different area formulas. Let's look at a second example. We'll start with a sketch. Here's angle A, 71 degrees. Its opposite side is going to be 37. So as soon as we see that, we know we're going to have to try 2 cases probably. So here's 71, 37, and I'll put side B over here. Here's our second option. We'll start with the acute case. Run this through the calculator and see what you get. So if something strange happened, that's okay. Let's look at what that was. Uh-oh, we got undefined. Here's what that means. That means it is actually impossible to have a triangle with these measurements. Here's what it really looks like. We've got a 71-degree angle. We've got a side of 40, and this side of 37 isn't long enough to reach. It can't connect to the base because it's too short. No triangle possible. So, good news, if your calculator gives you that error, you're done. It's completely undefined. There's no need to even deal with the second case. Let's look at a third example. We'll start with a sketch. We have a 70-degree angle. Its opposite side is 74. And its adjacent side is 21. Well, this adjacent side. I'm going to call this E, and that'll be F. That opposite side is very large, and so it makes a second case seem a bit unlikely. That 74 seems too big to fit if we try to sketch it with an obtuse angle E. Let's see how this plays out with the numbers. Let's start by storing this. And now let's find its supplement for case 2. Now, back to case 1. Let's go ahead and solve the rest of the triangle. This is a good exercise for you to do yourself. Please pause and give this a try. Here's my solution. Remember to store for precision. This time I think I'll finish with law of sines. There's side F. That seems like a pretty big number, so let's take a look at the triangle. Oh, there we go. Yeah, if we have one side of 74 and a short side, 78 is actually pretty believable. Let's look at case 2 now. We already got the alternate angle E, the obtuse version of angle E, by subtracting from 180. So let's finish the triangle. Let's get angle F. That's going to be 180 minus the other two. Hold on a second. Something seems wrong. Oh, something is definitely wrong. F cannot be a negative angle. Here's what that means. That means that there is no obtuse case, and we are finished with this problem. The only solution was the first one. So we're done. The last example I'm going to leave up to you. Draw a sketch, do the computations, and figure out, is it going to have 0 solutions, 2 solutions, or perhaps only 1 solution? Pause the video and give this a try, and then I will put the answers here. Okay, here are the answers. Thanks for watching.